Vital Signs is a community in Maine of students, educators, citizens, and professional scientists who are connected by and actively contributing to a shared research question. Since 2009, our focus has been on invasive species in upland, freshwater, and coastal systems. Our big driving research question is, where are these species in Maine and where aren't they? We only have a handful of scientists dedicated to this question and a lot of land, water, and coastline to cover. This is a perfect opportunity to tap into a statewide network of students and citizens who can help look for invasive species in local ecosystems. If we give them the tools and the scaffolding they need, they can make important contributions to mapping, monitoring, and early detection efforts.
Here's our Vital Signs map of species observations, showing the distribution of observations published since 2009. In that spot where you don't see any observations, the population density of the state is less than 1 person per square mile. No people, no data. This community of practice has experts and novices from across Maine, with our expert community extending into New Hampshire, Massachusetts, Connecticut, and New York. So far, our focus has been on making Vital Signs work for students and scientists. And to that end, we have about 50 active scientists and species experts, 200 educators who have come to institutes, and their thousands of students. And more recently, we've been experimenting with ways to get citizen groups to take the tool and run with it. We've had 70 master gardeners and watershed group members come to institutes.
So how does Vital Signs work? There are lots of right ways to use Vital Signs. One of its strengths, we think, is that it has many different entry points and pathways through. On our new homepage, we show one of the more popular pathways that students and citizens are taking through Vital Signs. First, they choose a mission. These field and analysis missions are research questions posed by the Vital Signs scientific community. They're a way for students and citizens to focus their data collection efforts on questions of interest to specific researchers or organizations. Next, they answer their questions with data and make meaning of their data in context of the larger database of Vital Signs species observations. Then they create multimedia projects, share their findings, and connect with the Vital Signs community. So we thought we'd spend the next 30 minutes telling you some stories that illustrate some of the more common pathways through Vital Signs, and at the same time hit on the topics that we were invited here to discuss. These topics include balancing research and education so that the data collected are being used to answer real research questions, connecting participants and researchers in meaningful ways, having an interesting and provoking website that allows participants to access information and resources, visualize data, and share findings, encouraging participants to go beyond data collection to diving deeper into the full scientific process, and finally, we have some concrete stories of data use by researchers. So here we go. Christine has our first story to show you how Vital Signs works.
Rhonda's 8th grade students looked through the field missions and they decided to tackle the rock snot mission this year, because really, who wouldn't? The rock snot mission was posted by Paul Gregory at the Maine Department of Environmental Protection. Rock snot, also known as Didymo, is not in Maine yet, as far as the DEP knows, and they're doing what they can to raise awareness. The DEP finds Vital Signs useful as a statewide early detection and community awareness tool. So Rhonda's students went to the stream behind their school with a species card for rock snot. Species cards are a resource that we've tested and developed with the help of scientists, citizens, and students. So Rhonda's students, with their species card in hand, looked for that one species. That one species being Didymo, or rock snot. They compared what they found in the stream with the characteristics on their species card, and they decided whether they thought they found rock snot or did not find rock snot. Here's a quick window into their investigation.
Welcome to Mill Stream, our watershed next to the Dedham School, and we're here with the entire 8th grade class of Dedham School, and we are looking for invasive and native species. I love the Vital Signs program because why I got into teaching science was to teach kids about the place they're from and to have a really strong sense of place
So after they did this field work, Team Equinox made a claim. They said, "We think we found it." And then they provided 3 pieces of written and photo evidence to support their claim that they think they found rock snot. They carefully reviewed their data, had a peer review in their classroom, hit publish, and then their observation was immediately made public on the Vital Signs website. So Paul Gregory at the DEP, 90 miles away in Augusta, was notified by email that there was a new observation of rock snot waiting for his review. He clicked on it, he read through the claim and supporting evidence, and he was excited, concerned, and anxious all at the same time. This might be the real deal, the first sighting of rock snot in the state. So he left Team Equinox a comment asking for more information and also for them to send him a sample. Paul got other scientists involved to check the sample, and then conversations went back and forth online between Equinox and DEP. Ultimately, they decided this was a close relative, but not rock snot. And Paul was so relieved to be able to question this particular identification. Species experts either confirm or question identifications, and separate from this expert review process, anyone in the community can either agree with an ID or suggest a different one based on the evidence provided. So these Dedham students were an empowered bunch, and they went on to create a video that shared their experience. They took it straight to their school board to explain to them that they prefer learning science this way by contributing to a real research effort. And you could check out their full video in the project bank on our site or right from the home page.
Vital Signs looks different in every classroom. Jamian's grades 5 and 6 students have used Vital Signs to map native and invasive species on their island in southern Maine. This year, they're extending their work to explore the impact of invasive species on ecological communities and to do habitat restoration on Mackworth Island. Here's Jamian to tell you about their project.
Oh yeah, this fall, the 5th and 6th graders at Friends School of Portland did a invasives eradication project. And as part of that project, we used Vital Signs to inventory all the native and invasive plants on our plot. We had a 50-meter by 50-meter plot. And so the kids identified and documented their plants, uploaded them to Vital Signs, had mystery species that they shared with a school on Vinyl Haven, and they've been going back and forth trying to identify plants. And then they went and we did an eradication project, and the state came and they poisoned what we cut. And in the spring, we're going to be planting a bunch of native plants and watching it, monitoring it over the years and seeing how it changes the ecosystem.
As Jamian mentioned, they also connected with students on another island further north, Vinyl Haven, to compare their island species and to build their identification skills together. Jamian and Amy and their students have met just once in person. Actually, it's twice now. They've met twice in person. But they have a lot of energy around pursuing more and deeper scientific questions together online. They're planning a Vital Signs field mission comparing biodiversity across their 2 islands, and they're hoping to engage other island schools. Students who have been introduced to Vital Signs in the classroom are starting to use it on their own time to explore their local environments and participate in the online community. A student known at her school as the Bug Girl because she's crazy about bugs used Vital Signs in the summertime in order to continue to explore her interest in bugs. Here's some online community action that occurred last July.
Just as I was about to set off on an early morning bike ride, I noticed a little fuzzy caterpillar crossing the road. Thinking it a tent caterpillar, I rode closer to view its brilliant color. Upon closer inspection, I quickly identified this as a gypsy moth caterpillar. I recognized it from a Vital Signs ID card. Scooping it up, I rushed home. I took a few hurried photos with a cell phone camera.
I don't know anything about caterpillars, but I do know that this is an awesome observation and some pretty great photos for a phone. Your third photo is especially cool, a glimpse of the scientist's desk. Good work, bicycle scientist.
This is a gypsy moth caterpillar. I've had more reports than usual this year of caterpillars, but no significant defoliation. We may see more leaf chewing next year as the population expands.
Great work, 7HW2. I knew you would continue looking closely at nature around you. 7HW2 is our resident bug expert at Massabesic. I think the whole vital signs community needs to keep checking out 7HW2 submissions for more cool pictures. Wait until you see the picture of Galarusella taken on our campus. You'll be amazed.
Thank you for the nice comment, parents. I was surprised when I found this caterpillar. I had never seen one in person before.
We have many more stories like these that we would be happy to share with you about how students and educators are using vital science tools to learn science in authentic, applied, and relevant ways that engage and excite them.
And if you're interested in the professional development for teachers that supports this level of student participation, we just finished writing a paper in collaboration with Henry Jenkins and the Playgroup at the University of Southern California that we'd be happy to share with you. Here's one of the videos from that paper. So one thing worth noting about our approach to professional development is that we're committed to developing long-term relationships with teachers and building lasting learning communities. For us, it's not about pumping teachers through institutes. It's about helping them use a tool and participate in a community in ways that change their teaching practice and change how their students learn and think about science. We have a number of teachers who have been doing vital signs for years who are already using who've been happy to discover that the learning in their classroom is aligned with the framework for the next generation science standards. They're really excited to bring their colleagues on board as this transition happens. We've started engaging some of our teachers as educator leaders, empowering them to lead their own institutes.
Much of our work in design so far has been with students and teachers. Through that work with schools, we have lots of 10 to 15-year-old citizen scientists. But we're also attracting a community of adult citizen scientists. Here's an example. There are two citizen groups in the rural Keyser Lake watershed in northwestern Maine who haven't always gotten along very well. It's a classic Maine tale of the year-round residents at odds with the summer people from away. But they all care deeply about their watershed and specifically the beautiful Keyser Lake. A few of them had an idea that they could build some bridges between the groups around milfoil and hydrilla awareness and a combined education effort. These are species they'd never want to see up north. They heard about vital signs and they approached us to see if we had any ideas that might bring their community together. We're always up for experiments that will stretch us in new ways, so we held an institute for 12 of them in early spring of 2011 to get them up to speed with the vital signs tools and identification card resources. You see here a beautiful early spring day in Maine.
So last summer, this group got 35 people out on the water twice to look for plants and bring them back to shore. We ended up putting their data online for them so they could get a sense of what it felt like to have their hard work documented. This wasn't an ideal situation. We would have preferred that their community put their own data online, but sometimes these things need to build slowly. We are excited and working hard to figure out what about vital signs works in this community and what doesn't. So they really love our species cards, but at the same time, they think they're really too big to be lugged around in a kayak or canoe. They really like the idea of collecting photo evidence and having all of their data published online in the same place in a publicly accessible database. They love that their data goes directly to the Department of Environmental Protection and the Volunteer Lake Monitoring Program to be confirmed or questioned by experts. But we learned pretty quickly that they don't want to be on their computers in the summertime. So we have an idea for what to do this summer. There's a teacher in the area doing vital signs. We're thinking that maybe we can leverage student involvement in the picture taking and the data entry that met some resistance from the adults in the community last summer. We imagine that some students like Bug Girl, would really jump at the chance to help out.
Word spread quickly that the Keyser group is up to something special with their summer communities. People in the Belgrade Lakes area in central Maine are now planning a similar approach and are taking it to the next level by involving college students, college professors, multiple area schools, and even more citizens. We're starting to see some promising outcomes from these ongoing experiments. And so far, the most engaging and motivating aspect of vital signs for these citizen groups, teachers, and students is that their observations are being looked at and used by professional researchers and managers. Our species experts see all of the observations that are published and then thank the participants, coach them to collect even better observations next time, or encourage them to look more closely or in different areas. It changes the game to know someone is using your data and is willing to take a second to leave a comment or suggest an ID. Here are a few ways that the data are being used.
So early on in our development process, the Department of Environmental Protection was on board. The Maine DEP is using vital signs data as first word data. They get pinged when an observation is published on a species they're interested in, and if there's reason for concern, they can learn more using the comments. They can ask for samples or photos like they did in the Didymo story, and then follow up in the field only if it's necessary. They also, early on, contributed a historical data set for variable leaf milfoil to the vital signs database, which immediately enabled more meaningful analysis of the vital signs data. We put this quick video together for them, and they've been using it themselves to show how variable milfoil has been changing and moving since 1970. Take a look. The orange points that you see showing up are where milfoil has been looked for and found. And starting in 2009, you'll start to see white markers showing up. And those are places where milfoil has been looked for but not found yet. They also shared with us their model for lake vulnerability. Both the historical data set and this model inspired analysis missions that anyone can do to learn more about species change over time and how at risk a lake is for invasive species. From DEP's perspective, they think that vital signs can significantly change their relationship with communities and individuals. They often have to go into a community and say, hey, you have a problem and you need to do something about it. This typically creates tension and unproductive relationships. If the reverse starts to happen, if the community can use data and models on the vital signs site, the hope is that they will start to approach DEP and say, we know our lake is at risk. What can we do about it? In this scenario, DEP involvement would be invited and welcomed, and they become a great partner in a community-led effort.
The Maine Forest Service is using a similar approach to the data as the DEP. Allison Keynote and two of her colleagues are using vital signs observations of invasive forest pests like hemlock woolly adelgid, Asian longhorn beetle, and emerald ash borer. Maine has a lot of trees, and Mainers and tourists move firewood and forest bugs all over the place. When Allison gets a vital signs notification, she knows who's out there looking and can check trees and interact with people all over Maine from her office computer. We also approached Anita Klein at the University of New Hampshire to see if she and her graduate students would share their Codium data set with us. She said yes immediately, and she was more excited than we expected. We learned that once funding for a graduate project is gone, her students' data might sit unused and unpublished. Vital Signs opens up opportunities for her students' data to be used and built upon by others. She's also asked Vital Signs participants to send her small samples of Codium for DNA analysis.
Robin Hadlock-Seeley at Cornell has been looking through all of the photographs on the green crab observations because she's interested in where and when the juveniles are showing up. Not every site has green crab recruitment every year, and she's trying to learn why. The Vital Signs data can help. She's also using Asian shore crab observation to decide where to target some of her fieldwork. And finally, EdMaps, the Early Detection and Distribution Mapping System, is interested in collecting all invasive species observations data into a single searchable database. So they checked out our methods and review process, and they see Vital Signs data as a legitimate source for their bigger database. They periodically export all of our observations where an invasive species has been found and confirmed by a species expert. This point on the map is a Vital Signs observation of Japanese knotweed in Jackman, Maine.
To recap, we've found that professionals are most interested and excited about getting notified when species they're interested in are being looked for and found or not found, having a new way to target their own research and resources more effectively, knowing there's a growing network of active, aware citizens that are looking in places that the scientists can't get to alone, and they're also really excited about seeing high-quality data that's already gone through a careful data review process. You can see from this graph that citizens and students are pretty good at identifying species using our resources.
So those are some of the different ways that the online interface and data are being used by professionals. It's important to note that all of these stories of data use have come to us in informal conversations, and we're hoping to be more proactive about learning how professionals are using the data. So why is this working, or why does it seem to be working for all of these very different groups? And what are some of the lessons we've learned along the way? It's easy for us to overlook now, but it's essential that we started with a question that scientists need help with, that citizens are also interested in, and with the right tools are able to help with. Another reason that Vital Signs is working is that we involved all groups, students, teachers, citizen scientists, and scientists, in the design process from the very beginning. When we met with scientists and teachers together, we asked them questions like, what data would you trust and use from students and citizen scientists? Which native and invasive species can a novice identify successfully? What sampling methods can students do successfully in 40 minutes? So here is one group of kids who tested our quadrat sampling method and prototype species cards. We watched what these students did in the field with the resources and with the online tools. We found that observing people doing things was much more helpful than simply asking them questions. So through this process, we knew that it worked pretty well and was a useful tool for all groups before we launched it. But at the same time, we knew that we were dealing with humans and technology and the environment, all things that shift and change often. So we had to be really flexible in our design. We needed a system that we could experiment with and that could grow along with us.
Here is a screenshot of our original website homepage. It's very different than the way it looks today, the view that we showed you earlier. A year after launching the website, we were already changing website content in response to what participants were using and what they were not using. 3 years in, we did a major site redesign. The site was initially designed to explain our vision for the community and learning environment and to introduce all the tools available to support participants' efforts. It was an invitation to a community that had not yet taken shape. But as the community grew, it was clear that active participants needed a different flavor of site to support their interests and needs. The site is now more social. It's mission-driven. It highlights key resources, and it celebrates data quality. We use automated reports and graphs like these of participant use over time to see how things are changing. This graph shows the numbers of species surveys published since each season since 2009, and we're seeing a steady increase in this type of data with big pulses during the fall field seasons. It's a very busy time. This graph shows how commenting has increased over time. The social component of the site is really taking off.
So we use information in graphs like this and emails from teachers and observations to figure out what our next steps are. So next steps for us, we'd love to continue moving into new spaces like the community efforts we talked about in Keyser and Belgrade, as well as informal out-of-school learning environments. This is a photo of a group of out-of-school educators that we're working with to learn more about what vital signs might look like in an after-school program, a recreation program, or summer camp. We're also hoping to build some new tools on our My Vital Signs and public profile pages to help sustain participation over time and motivate students to do vital signs on their own. What if on their public profile pages, students could actually see how their participation has changed or deepened over time? What if scientists were recognized publicly here for their contributions? We think that there's a lot of promise for motivating and sustaining participation. We've also been working for the past year with Bridget Barron and Caitlin Martin at the Stanford School for Education, looking into student interests and motivations around technology and science. We're also working with them this spring on ways to capture and assess the learning that is happening both offline and online. We know that students and citizens are contributing high-quality data, but what are they learning in the process? And are there some online tools that we can use to learn more?
We're also experimenting with and thinking about how to get students to make species cards. And it's actually happening as we speak at a school in Portland. Here's a clip that shows 70 7th grade students who are excited about making species identification cards and adding them to the online resources. Another future project might be building an iPad app that lets participants capture data offline and then send it to the database when they have an internet connection.
And finally, we're curious whether pieces and parts of the vital signs system or our best practices around teaching and learning would be useful to communities beyond Maine. Vital Signs is an open education resource. We built the site using Drupal, which is a free open web platform, and all of our content has a Creative Commons attribution license. So we're hoping that people will use, share, and remix Vital Signs in new ways to make it work for them.
Thank you from the whole Vital Signs team for inviting us to meet with this incredible group and to share our stories. We've heard and learned so much these past 2 days from all of you, and that will inevitably have a big influence on our next experiments and iterations of Vital Signs. We'd love to share more with you as it's of interest, so be sure to keep in touch.